Do you like tapping the table? How about clicking a mouse until your hand hurts? Or how about clicking a mouse until it breaks? If so, then clicker games are for you. And in fact, as you can imagine, these will get boring pretty quickly, so people have decided to spice them up. Here are a few examples of clicker games. I'm sure now you can see why they're called clicker games. Now, despite the bright colors and beautiful graphics, a lot of the gameplay still ends up looking a little bit like this. Now, the goal of this week is to make a game that makes the player do this. People who made Cookie Clicker also made a clicker game engine, so we could use this. But instead, I'm going to make a clicker game in Java. If you have no programming experience, I'll still leave a link down in the description. So the first thing I had to do was reverse engineer the user interface. And since I'm lazy, I decided to break it up into these three parts that you can see here. First one is the clicker window, the second is where all the buildings are, and the last one on the right is where the shop and upgrades are. Now, since I'm lazy because I'm a programmer and I see that everything is uniformly laid out, I can come up with a formula so that I don't have to place each individual building or button. Let's say we want to draw a potato. We know that a potato actually looks like this because the potato is just a picture, and a picture is a rectangle. Now from this we can see that the potato picture has a width and a height like a normal photograph, and an X and Y position. Notice that the X and Y positions are on the top left of the photograph. And this is because drawing pixels on the screen is just like writing. You start from the top left, and then move across the screen until you get to the end. Now let's say we want to draw multiple potatoes. We need to figure out where to place each one. Now, we know that the top right corner of the first one is in the same spot as the top left corner of the second one. Therefore, to calculate the position of the next potato, we just need to calculate the top right corner, which is the X of the first one plus the width of the potato. The same thing goes if we want to calculate the X position of the third potato. This simplifies to X plus 2 times width. If we label the potatoes, the formula starts to become more obvious. And the good part about this is if we don't want them on the edge of the screen, we can set X to some offset value. One thing you might notice when playing these games is that the counter doesn't update every second. For example, if you have a grandma producing 8 cookies every second, it doesn't wait a second and then add 8 cookies. She actually makes a cookie every 1/8 seconds. And this would be a good guess, except what happens if you're making 1 trillion cookies a second and the computer can't update that fast? What we can do, and in fact this is what I did in the remake, is take the rate of cookies per second and convert it to cookies per millisecond. This makes it so the cookies add up much faster than the player can notice. Let me flash a bunch of pictures on the screen for a millisecond to show you my point. Now you're probably thinking, well, what happens if you only get a fraction of a cookie in a millisecond? There isn't 1.69 cookies displayed. And that is the final step that brings this all together. Behind the scenes, the game keeps track of fractions of a cookie and then rounds the answer when it shows it on the screen. Oh, sorry, this is the alpha version of the game. Here's the real version, which you can download from the link in the description. If this video gets 50 likes, I'll do a Super Mario Bros. Remake next.